Hey everybody, thanks for tuning in. It's the first time I've tried to do a video. I'm going to walk you through some of the maybe lesser known functions in baseballr. These are functions I added probably about a year or two ago, and they revolve around the official MLB stats API that's out there. This is not a very well publicized or well documented API. It does exist. There's a lot of useful functionality that you can gain from it. I've tried to incorporate a lot of that into baseballr. There's still lots more that I can do, just a matter of time and things like that. So I'm going to walk you through a couple of these. Hopefully you find it useful, and hopefully the video and the code is readable and comes across well. All right, so let's dive in. Going to just use two packages for this, obviously baseballr and tidyverse, just to make some of the data manipulation a little bit easier. I turn off scientific notation. It's just a me thing. It makes it easier to read certain fields. You don't have to do it though if you don't want to. So the first thing is when you're looking at a lot of the MLB data, and you see this in the StatCast downloads, there's a unique identifier that they create for every game. It's called a game pack. That game pack ID allows you to link games across all sorts of different data sets, and it's particularly useful when trying to pull data within the MLB stats API. So there is a function within baseballr that allows you to grab those for any given date. Again, very, very simple. In the baseballr package, get game packs MLB, you give it a date, and then you give it a level ID. The level ID tells it at what level do you want game packs for on that date. You can grab minor league baseball data with this function, get those game packs, and I've written a little bit about that and might do a video if folks find it useful some other time. But here we've got level ID 1 because that is the ID for Major League Baseball. And we're going to pull game packs for all games that were played on August 1st of 2020. So you can see here, this is what that raw data will look like. You've got your unique ID for each game here. You've got the link to the live feed, and that's actually the link that we're pulling from to grab the play-by-play data that comes from the stats API, not the StatCast data. Quick note about that: most of that data is going to be similar. There's going to be a few differences. One of which is the StatCast data does get fixed or edited if there's any bugs in the data. Sometimes they make corrections to different data points after the fact because you can always get something that gets a little buggy when you're doing it live. As of right now, spin axis is not available in the StatCast download, but it is available in the play-by-play data you get directly from the API for the 2020 season. So just something to note there. Not going to go through all the data that you can grab here, but there's a lot of useful stuff that they include when you're pulling down the game packs. Now, if you want to grab game packs for example, an entire season, you'd obviously have to loop through all the dates where games are played and accumulate that together in a single data set. If you want to save yourself that time, I actually have a running data set out on Box where every morning during the season, I've got a job that runs. It pulls all the new game packs from the night before, and it appends those games and supplemental data about the games into a single file that's out there on Box. You can go to the baseball tools section of my webpage to grab links to that, or you can use this function within baseballr called get game info sup petty. This is just supplemental info, and it's data that I've already grabbed for you. So this is just reading in that data set from Box. So if we pull that down, see it doesn't take all that long to run, and you've got over 36,000 unique IDs, games in that data set. Now this goes back all the way to 2008. And this is where you grab some of that other interesting data. For example, what was the temperature at game time? They've got some notes in here about other weather. So was it cloudy? Was it sunny? Was it windy? More importantly, if you're doing any studies about the effects of domes, for example, it will tell you if it was in fact a dome stadium, but more importantly, was the roof closed? So we've got stadiums where they can retract the roof, they can leave it open depending upon weather, temperature, things like that. So you can actually see for each game whether or not the roof is closed or not, which makes a difference. Wind, you'll get general speed and direction. Now, again, obviously during games that stuff can change a little bit, but again, as a first starter here, this is not too bad. Attendance, Obviously, for 2020, you're not going to have any. There were some games, I think, that they began to allow a small number of customers in, but for the most part, attendance is going to be a wash for this year. But if you're doing any studies around attendance and you want to go back, as I said, from 2019 back about a decade, you're going to get that information in here, which is really helpful. All right. So that's how you can get game pack information for a particular date, but also how you can get it in mass if you don't want to sit there and write your own loop for it. The other thing that you can do is grab umpire IDs. Now, in the old days, I believe they included umpire ID when StatCast and Baseball Savant launched, where they were providing the StatCast data. That data very quickly disappeared, but that data is available through the official Stats API. Again, you just have to kind of know where to look for it and how to link it up to each individual game. Thankfully, with the game packs, that makes it really easy to do. So you can grab umpire IDs, and again, I've got a running list that I can provide for you. I accumulate that every morning and then make it easy for you guys to join that data together. So if you've got StatCast download data, even historical StatCast download data, and you'd like to know who the home plate umpires were for those games, maybe add that in as something to control for if you're doing some catcher framing modeling. You can do that with the get umpire IDs petty function. And again, it'll read this pretty quickly. And you can see here you've got the individual umpire's ID, what position they were actually at when they were umpiring, right? So you've got an umpire crew, 4 umpires, first base, third base, first base, home plate. They move around within a series to different positions. So this will let you know in the position field here, HP stands for home plate. You can easily identify those folks then. And you've got the game pack ID. So matching this up with StatCast data on a pitch by pitch level, very, very simple to do. All right. The next thing you can do is grab batting orders. So this is also something that's embedded within the Stats API. So when managers are handing in those lineup cards every day, there's official batting order information that gets uploaded early, even before the game starts. But then also, I believe they append it as the game goes on. When you've got pinch hitters, you'd be able to see who they pinch hit for and where within the lineup they ended up hitting. Get batting orders. Is a very, very simple function. The only thing you have to feed it, again, is a game pack. So once you've got those game packs, there's a lot that you can do with that. So we'll just grab one here. And we'll just increase this for the time being. So here you can see you've got the White Sox versus the Tigers. You've got the player ID, which is essentially is the MLB ID for matching across all the different official data sets that are out there. You've got the full name of the athlete. You've got the abbreviation, which is really a stand-in for what position they were penciled in to play to start. Again, you can see how I haven't done a whole lot of manipulation about the variable names in this stuff. I'm really just pushing out the raw data as it comes. That's probably something that I can make a tweak to just so it's a little bit easier to interpret. Batting order, so again, just the rank order of where they were. Batting position, so this is where if you've got somebody that's coming in and pinch hitting, there'll be some notation here. Just to let you know, kind of where in the order they were, who they were pinch hitting for, and if they got moved around, maybe in a double switch, for example. Lets you know if the team is the away team or the home team. It also includes the team IDs here too. Again, if you're trying to do any other type of matching across data sets, that can be kind of useful. You can also get probable pitchers. So this is also useful if you're doing any historical analysis and you want to understand, who was the scheduled probable pitcher for those games. But this is also helpful if you're doing any analysis pre-game. Again, some folks are into, daily fantasy sports. Maybe they're trying to put lineups together. Maybe they've got models that try to estimate how hitters are going to perform based upon who the pitcher is going to be. Sometimes you'll get late scratches in probables, or maybe you've got to get your lineups in early, and so you're trying to get the earliest announced probable if they're going to a 5th starter, or it's unclear who might pitch that particular day. In any event, you can use the get probables MLB function to grab that, and again, all you got to do is feed it the game pack. So those game packs become really, really helpful. This will just return a very, very simple data frame, just 2 rows here. It'll give you a row per pitcher per team. It'll give you the pitcher's ID, the team ID. It also will give you the home plate umpire. So this is also one of those nice little side effects of the probable pitcher function. If you're looking to grab the home plate IDs or home plate umpire IDs, and you don't want to grab the entire historical data set for whatever reason, or if you want to build your own, you can grab this information from within the get probables MLB function. The next one is around the draft. So, there are some great resources out there. Baseball Reference, probably the number one, that's got a really great searchable user interface for grabbing information about the draft. The MLB Stats API does also have some information about the draft. I haven't looked into it too much at this point. I think most of it is related to the typical June draft. Amateur draft, but it's an area where I want to dig a little bit more into the API and see what else might be there. In any event, all you have to do is feed it the year that you're interested in, and it's going to pull down a lot of information about all the individuals that were taken in that year's draft. So we get a nice simple data frame returned by the function. You actually get a couple of IDs here. You get, I believe this is it's the BIS player ID. Later on in the data set, you'll also get the MLBAM player ID, but that's potentially useful if you're doing some matching again across other data sets. It gives you the round. It also gives you the number within the round that they were taken. If you're interested, you can go grab their headshot. This is a static link to the JPEG of these players' headshots, if there is in fact one. Again, did they get drafted? What school did they come out of? If it's a high school, usually there'll be this little HS notation here in the name. The person ID here, this is really the MLBAM ID that they're being assigned. And again, this is something where I can probably clean up some of the variable names in the that the function is going to return if I can get around, get time or get around to it. But this will typically be their MLBAM ID going forward. You'll get their full name. You'll get essentially a static link to their player profile available from the API. Breakout of their first and last name. Person primary number. So this I wasn't entirely sure about. I don't actually know if these are their numbers, for example, from if they had this number in college or not. I haven't looked into it too much, but it would be interesting just to verify what that is. When they were born, so this is helpful. Person's current age, so they give you kind of the integer age that these folks are at when they're drafted. Birth city, birth state, and country or province, depending if they were born outside of the U.S. You also get height and weight data in here. Now, again, the height data, instead of being in inches, it's in feet and inches, but you could easily convert that if you wanted to. Let's see what else. There's something else in here that was potentially useful. Obviously, the year they were drafted. If you're going back historically and you are trying to, find individuals that were drafted and see, if they actually made their MLB debut or if they never made it to the big leagues, they do have a column in here for what the date is that they made their debut. Now, most people drafted in the last year or two, they're not going to have made their debut already. Some people will. There's always a couple of folks that make it pretty quickly. But again, if you're kind of pulling all this draft data together historically, that's a nice field to have if you're doing any kind of a study to look at, by team or by draft position, who actually makes it to the show, who never made it to the show. First and last name, person named Slug. That might have been all the most useful information here. You also get the top and bottom of their strike zone. So again, you'll notice that in a lot of the data for the MLB Stats API, when you're doing play-by-play and pulling that data, every individual hitter has a slightly different top and bottom of their strike zone. And again, that's just based on their height. Because obviously, the rule book is, states that the strike zone should be variable depending upon the batter. So for a lot of the automated balls and strikes coding that they do, there's the umpires, they're going to call if it's a ball or a strike, but when they're drawing that box, they want to draw that box so that it shifts a little bit, or the pitches are coming in relative to what's a ball or a strike for that hitter. So if you're doing, again, any kind of, catcher framing, if you're doing any kind of called strike research, knowing what the adjusted strike zone top and bottom should be for a hitter is useful, and you can get that in various ways through the MLB Stats API. I think that's most of the good stuff I wanted to show you in here. So final thing I wanted to walk you through is just so what can you do with some of the play-by-play data that you get from the MLB Stats API that maybe you can't get from just doing the StatCast downloads from Baseball Savant? Well, one of the things, and this actually came up, I had somebody reach out to me maybe a year or two ago that was looking to do research in this area. There's other things that happen in a game outside of a pitch. So all of the data that's available on Savant is data where the action of the play was a pitch. But you can have non-action events. So for example, when a coach comes out to do a mound visit, or do a pitching change, or there's an injury, or there's a defensive substitution, those things aren't noted in the StatCast data available on Savant as separate rows or line items. And so if you're doing any kind of research around that, makes it a little bit hard to to grab that information. Now, this is available, though, in the MLB Stats API, and one of the reasons is when you're watching, for example, through your game day app, you'll see these kind of game alerts all the time. Mound visit, injury, injury on the field, pitcher substitution. So those are recorded as separate rows in the data. So let me show you what that looks like here. So first thing we want to do is we've got this game packs information that we already downloaded for August 1st of last year. And we're going to just pull game packs here. We're going to filter for those that have a detailed state or status of final. This is just to avoid pulling games where maybe it was in a rain delay or something like that. And then we use the pull function. And the pull function just takes all of those game packs and pulls it as a vector rather than keep all the data in the other columns. It just keeps it as a nice simple vector for us. All right, so you can see here we've got 11 game packs where those games were final. The next thing we're going to do is we're going to pull all the play-by-play or pitch-by-pitch data from those games from the official MLB Stats API, and we're just going to loop over it using the map df function. This actually comes from, I should note this in here for you, the purr package. And again, purr is part of the tidyverse. It's just an easier way for doing any kind of looped or iterated operations if you want to use something outside of for loops or lapply or anything like that. So the first thing is you have to say, well, what essentially are we looping over? And that's what this .x argument is. So game packs final, that's the vector of 11 individual game packs that we want to loop over. And then you have to feed it a function. And so here we're going to use the baseballr get play-by-play or pitch-by-pitch MLB function. And all we have to do is, for the one argument that we care about, the game pack argument, we're going to put .x here. And so what this does is it says, all right, so for every one of the game packs in this vector, we're going to loop over and repeat this operation using the next value in that vector until we've got all 11 of them. So for 11 games, it's not going to take that long, a couple of seconds. It'll pull that information for each of the 11 games and then bind them together into a data frame for you. And so let's just take a look at what our payload looks like here. So this will look somewhat familiar in terms of the StatCast data, but there's just a lot of other data in here. The data is not as clean as what they've already given you on Baseball Savant. The column names are going to be a little bit different, but it's again the bulk of the information here is going to be the same. So was this a pitch? Is it true or is it false? Now what you're going to find here is that in a lot of cases, most of the data here are pitches. But we've got these other things called actions, and that's where things like mound visits and defensive substitutions are going to be. And you'll note, from an index standpoint, oftentimes they're going to be 0, meaning if we're looking at an at-bat and the sequence of events in that at-bat, if it was, for example, a mound visit or a pitching change at the beginning of that at-bat, it's not going to be, it's going to have an index value of 0. It's happening essentially before the rest of the action actually takes place. We can scroll over here, and you can see now in the description about this event, it's a mound visit, right? So there was a mound visit that happened before we actually started to go through our sequence of pitches within this particular at-bat. So this is the stuff that we're interested in here. Mound visits, offensive substitutions, they're going to be of type action. So if we want, let's pull out all the non-pitch events here. And I'm going to whittle down some of the columns here because, again, when you're looking at that payload you get from the pitch-by-pitch function, it's about 150 variables, and we don't need all of that for what we're going to look at here. But we are going to pull things down like the game pack, the at-bat index, the pitch number, what the matchup was in terms of the pitcher and the batter. And we can see, for example, what are some of the types that we get here. So we have a lot of mound visits. We have offensive substitutions. So when we've got a pinch hitter being announced, that'll be recorded here. We've got our pitching changes here. Let me just see. They note wild pitches separately. Obviously, they're counting that as a ball in the typical pitch by pitch data, but you've got just a separate call out here. You've got your defensive switches and defensive substitutions. Pickoff attempts are also noted here. So again, if you're trying to do some research that involves things like pickoff attempts, stolen bases, and you're curious about whether or not the pitcher threw over before a runner tried to steal a base and what effect that might have on their success rate. That's the kind of information that you can't necessarily get in the Savant downloads, but you can get it using this official API. All right, so again, silly example here, but what if we were curious about whether or not there was a difference in the rate at which batters reached base when there was a mound visit at some point, either before their at-bat or during their at-bat, and if there wasn't. So we can do a couple of things here. One, we can find out which of those at-bats did have a mound visit. So we're going to look at those non-pitch events. We're going to filter on that details description column for where the word mound appears. Right, so we're not just searching for the word mound, but anytime the word mound is appearing in that details description field, we want to filter and pull down that data. We're then going to say, all right, so for all of these cases, there was a mound visit, so we're going to code that as a 1. So that, again, it's going to be easier when we join this into the rest of the data that we have about that at-bat. And then all we need is information to join this back to the larger data set in a unique way. So we're going to grab the game pack, the at-bat index. So within each game pack, each at-bat is given a unique number from an index standpoint. So we'll use that to match it up. It will also include the batter's full name, just to be sure. And obviously the mound visit variable now, because we want to be able to note if there was a mound visit or not. So for this day, we've got 70 of them. So you can see here, game pack, which at-bat was it within that particular game, who the batter was, and yes, all of these will be a 1, meaning there was a mound visit within those at-bats. So now we want to join this information into the larger payload. So we're going to do a left join. We're going to look at joining on game pack, at-bat index, and matchup batter full name. We're then going to code mound visit using the case when function. So as long as mound visit equals 1, we're going to keep it as a 1. Everything else is going to be a 0, right? Because when you do this join, the mound visit variable for, again, about 70 of these at-bats, it's going to be a 1, but it's going to be NA for all the others. So we want to get rid of the NA and just simply have a 1 or a 0. And then we're going to turn mound visit into a factor just to make some of the analysis later on easy. Then we want to make sure that we're looking at the end of the plate appearance, right? Because if we're curious about whether or not you reached base during a plate appearance where there was or wasn't a mound visit, we just want to look at the very end of that plate appearance and see, well, what did you do, right? Did you make an out or did you reach base in some way? So here we're going to group by the game pack and the at-bat index. We're then going to find the max pitch number within that game pack and at-bat index. And then we're simply going to code it as a 1 so that we know that this was in fact the last pitch of that at-bat. And again, just to show you what this looks like here. So for this game pack, this at-bat index, pitch 4 was in fact the last pitch. So now we'll join that to our payload with mound data frame. We'll join by game pack, at-bat index, and then pitch number is going to equal our end of PA pitch. And again, we're going to filter and look at those where we only want data now where the last pitch was in fact the one thrown. So this greatly reduces the size of the data set, right? Now we're only looking at 850 entries. And you can see here, let me go all the way to the end here. There's a lot of variables in here. You can see that it was whether or not it was the last pitch. All right, so once we've done that, we want to code whether or not that particular plate appearance ended in the batter reaching base or not reaching base. Simplest way to do that, again, is to use a case when statement here. Results.eventType will provide the real simple, intuitive labeling of what the end result or what the event type was of that particular plate appearance. So anytime it was a single, double, triple, home run, or walk, we're going to count that as a 1. We're going to say that the batter safely reached base. Everything else is simply going to be a 0, meaning they didn't. Now that we have that coded in there, right, we've got reach base and we've got whether or not there was a mound visit during the at-bat. We can just do, again, just a simple comparison of means here to see when there was a mound visit, what was the reach base average, and when there wasn't a mound visit, what's the reach base average. So again, we're dealing with some pretty small numbers here, right? In the 70 plate appearances where there appeared to be a mound visit, the batter reached base at a 343 clip, which is pretty good. Where there wasn't a mound visit, batters reached base at a 295 clip. So that's a pretty big difference, right? It's almost a 50-point difference between the two. But this is only for games on a single day throughout the season. What if you wanted to compare this across a longer time span, say the entire 2020 season? So a couple of ways that we can do this. We're going to need this pitch-by-pitch data from the official MLB Stats API across the entire season, right? Not something we can grab from Savant. It's going to require us to, grab all the game packs for every single game, run the get, a pitch-by-pitch MLB function across all those game packs. It's a lot of work. So I want to show you a quick and easy way that you can do that, but I won't let this run all the way through. I'll save us some time here. You can use jobs within R and R Studio to have a looping function like that working in the background while still allowing you to work in the console. So first thing you need to do though is create a separate script here. Which I've got game pack loop 2020. You need to make sure that you're telling the program what your packages are that you're going to need, and then you simply script out the work that you want it to run in the background to not interfere with how you're maybe going to go and do some separate analysis or some separate coding while you're waiting for it to finish. The easiest way to do this is grab all the game packs from that supplemental file that I have sitting out there, and then simply filter it for all of those game dates that are in 2020 and where the status is F for final, right? We don't want games that were delayed. We don't want anything like that. We just want games that were actually played start to finish. We're then going to figure out what the number of games are, just because that'll give us a nice little message that we can create here. But we're going to use that mapDF function again to loop over all of the separate game packs, hit the MLB Stats API, grab all of the pitch-by-pitch data for them, and then bind them together in a single data set. So here's a little trick that you can use with these map functions. You can create what are essentially custom functions by placing curly brackets or placing your code within curly brackets where you're supposed to initialize what function you want to map multiple times. What I do here, just to give myself a little bit of an idea for how long something's taken, I create a message and then I say, all right, if I'm going to sequence along all of the game packs from 2020. Every time it does that, it's going to be telling me what number in the sequence we're at, where the function is running. And now that I know what the actual number of games happens to be across that whole data set, I can send myself a message that says, right now we're grabbing pitch by pitch data for game 3 out of 200 or 3 out of 3,000 or whatever. And you'll get that message so you can see as it's running, how quickly is it running, and how long is it going to take? Can I go get a cup of coffee, or is it about to be finished? You then essentially say, all right, grab the play-by-play data, dump that data, into as a payload in terms of data frame, and then the function should return that payload. That's what is this return payload. That's what's going to get stitched together, into a single data frame. So you've got this function. It's all set aside. You can actually see it down here in my directory. So you can do this, for example, within RStudio using source's local job. But there's also you can also run these using the job run script from within the RStudio API. For this to work, you have to just simply tell it what's the path to the function that you want to source as a job. You can name it so that you can see it here in the jobs pane, and then whether or not you want the results to be exported or really imported into your current working global environment. In this case, we'd want that to happen just to make our life easier. So we can go ahead and run this, and let me just show you what it looks like. So it's running now in this jobs pane, and you can see it's going to start telling us which game it's currently grabbing data for. Now there's over 1,100 of these games, so this is going to take a while. I think an entire season is somewhere between 10 and 15 minutes, depending on how things go. I don't want to sit here and necessarily wait for that to happen. So a couple of things we can do. We can let this run in the background, but I can show you how this is running in the background, but it's running essentially in a different session of R. We can go ahead and jump right in here and say, all right, I don't want to wait for this. So let's just go ahead and grab the entire season, which I've already done. And put it into a CSV just to save time here. All right, so we'll go ahead and read that in. And so you can see I'm reading things in right now, even though there's this large, looping job happening in the background. So that's the nice thing about, the jobs function. So I'm going to kill this job just because we don't need it to finish. But I just wanted to show you that as an example because I think it'll be useful for you. All right, so everything here is going to be the same, so I'm not going to spend a lot of time on it. We're going to run all those same functions to figure out, was there a mound visit, yes or no, in which at-bat, join that information into the larger payload data, and then figure out in code, well, what happened at the end of those plate appearances? Did the batter reach base or not? So we're going to run through that pretty quick. Okay, now we have our data that we can do our analysis on. So first thing is, let's see over the course of an entire season what the difference is in terms of the rate of reaching base. So the gap closes here. So before, in that one single day, we had a 50-point gap between the two. Here, we've got less than a 20-point gap. So it's not nothing, but it's just also not huge. It's not a massive effect. We could also do a quick chi-square test just to see if there's some kind of a statistically significant difference. We know what the if there's a meaningful difference, if we think that 20 points is meaningful over the course of a season. And again, it's not nothing. It's not a huge effect, but it's pretty sizable. But this will give us at least an initial indication. Is this just noise, or is there maybe something to something to this? That p-value there, pretty low, right? So likely there is something fundamentally different between these two populations of plate appearances, those where there's a mound visit and those where there isn't. And intuitively, this makes sense. You usually don't go out to talk to your pitcher if they're mowing guys down, if they're having a great game. It may be that most mound visits are happening when a pitcher is struggling. Maybe they don't have a good feel for their pitches that day. Batters are seeing the ball well, squaring them up. So we'd expect for those at bats are probably towards the end of that pitcher's day where they're not throwing as well and are more likely to give up a hit. The other way to think about it is mound visits are likely happening when guys are maybe starting to get tired. So their control is starting to leave them a little bit. Maybe their velocity's down a little bit. Coach comes out, say, hey, how you doing? How you feeling? Oh, I got one more in me, coach. Okay, we'll let you go one more, see how things go. So it makes sense intuitively that there should be a difference in the rate at which guys are reaching base in at bats where there is a mound visit at some point, during their plate appearance. Now, the other things we didn't get into a whole lot here. There's a lot more that you could do with this. Obviously, if we really wanted to know what the effect size is and if it is noise or not, you'd probably want to model this out, right? So we'd want to control for the identity of the batter and the pitcher. We want to control for the fatigue of the pitcher, right? So how many pitches have they thrown up to that point? We'd want to see maybe how that pitcher had thrown leading up to that, right? Were they having a good day, or were they sharp, or were they not as sharp leading up to that particular at bat? So a lot of things that we could do to have more confidence in what the effect size is here and if it's real or not. But the nice thing is, and hopefully this has been helpful, it shows you where you can grab this additional information to even make a study like that possible. So that's all I've got for you today. Hopefully this was helpful. Hopefully this showed you some things that you can do with the baseballr package, and in particular that official MLB stats API that maybe you weren't aware of. It'll help you with some of your own research and some of your own projects. I'm potentially planning to do more of these. It's going to just really be more a factor of time and in demand, and if folks are really interested in it. So let me know if this is something you'd want to see more often, and if there are particular subjects in particular about the baseballr package that might be helpful for you and could be interesting as well. So thanks again, and I'll see you soon.